Welcome to the channel for the future caretakers of resurrected species. Welcome to the Paleo-Zoo-Keepers Association.
Oh, hello there. Welcome to the Paleo-Zoo-Keeper Association. My name is Austin. Tyrannosaurus Rex. Again, need I say more? One of the most well-known dinosaurs known throughout the whole world. At a height of 13 feet tall, a length of 40 plus feet long, and weighing in about 8 tons, this Tyrannosaurus is definitely a large animal, amongst the largest of the theropods. Said to live in the late Cretaceous period of 66 million years ago, this animal pretty much lived in North America and was the main predator of large herbivorous dinosaurs such as Triceratops and Edmontosaurus. For those who are longtime fans of mine and subscribers, know that I actually made a video about Tyrannosaurs about a year or so ago. And for those who don't know, I'll send you a link either in this video or in the description box down below, so you can be able to get some more info. When you're keeping such a famous and well-known dinosaur in captivity, you would definitely want to be able to raise them right and to breed them properly in captivity. So in this video, we will discuss on raising and breeding Tyrannosaurus Rex in captivity. And we will start by raising Tyrannosaurus Rex. Now, the reason why we are starting with raising rather than breeding, is primarily because when resurrecting the Tyrannosaurus, it's most likely we're going to be resurrecting them and raising the baby T-Rexes long before we even started breeding any T-Rexes. So we'll go with this. When raising Tyrannosaurus in captivity, especially when you raise the first generation of T-Rexes that you resurrect, it's not going to be very easy. It's going to be a large era of trial and error. So there will be curveballs. Now, we could be able to get some ideas of how to do it with both the fossil record and for what we know about modern-day relatives such as birds and crocodiles. This will definitely help us out, but just remember, there will be curveballs, especially when you're dealing with the real thing, and not just something theoretical.
How do we resurrect Tyrannosaurus Rex in the first place? Well, we would start with the DNA found in the bone marrow in Tyrannosaurus Rex bones and use the genome of a chicken as a basal genome for the new Tyrannosaurus. We use the chicken since it is said to be the closest living relative to the T-Rex, based off of mitochondrial DNA, which is different from nuclear DNA. Only when we get nuclear DNA that one could say yes or no on using chicken DNA at this time. We would then use CRISPR technology to modify the chicken DNA with the ancient Tyrannosaur DNA. Then we will place the new DNA into the stem cells of ostriches, use those modified cells to create chimeric ostriches, basically ostriches that make T-Rex germ cells or sperm and eggs, and breed those ostriches naturally or artificially together.
Once you get these chimeric ostriches to be able to lay their eggs, that has a Tyrannosaurus Rex embryo inside, you're getting a good start. However, this is not where it gets easy. In fact, it actually will get a little hard because, according to scientists, a T-Rex egg is actually a lot bigger than the ostrich's 6-inch egg. 6-inch egg. In fact, according to scientists, a T-Rex's egg would actually be 17 inches long. So, a couple times, definitely over a couple times longer or bigger than an ostrich egg. 17 right here. So you can't be able to incubate the Tyrannosaurus Rex embryo in the ostrich egg completely. However, there is a workaround. There actually is a technique that has been tested with chicken embryos that we could use for the Tyrannosaurus rex embryo.
To grow an embryo out of the egg sounds like something out of science fiction, but chickens have been able to be grown outside of their eggshells in a plastic film in a plastic cup, which is in an incubator. The plastic film, or a plastic food wrap that has high oxygen permeability and strong enough to hold the growing embryo, is needed as it will allow the embryo to breathe and exchange gases, but make certain to get rid of the wrinkles, for those wrinkles would kill the embryo. Having supplemental calcium or calcium lactate powder in the bottom of the plastic wrap was found to help increase hatchability for this, and will help the chick get calcium. Filling the plastic film in the cup with distilled water is best, because tap water has chemicals in it that would kill the developing embryos. For the embryo to get the oxygen it needs, poke a hole on the top and stuff it with cotton so that it'll get oxygen, but the cotton will act like a filter with undesirable things in the air, like bacteria. Also, make absolutely certain that things are clean and sterile to avoid contamination and infection. Also, for the best results, best to get the embryos into the container when it's a couple of days old after being laid. Wait any longer and the chances decrease, and it'll get harder to get the embryo out safely.
However, before doing this, you will need to see if the eggs are fertilized or not. Using a process called candling, you will hook a light right up to the eggshell, and if you see blood vessels like being pointed here, then you definitely have a fertile egg. Whether by using this kind of technique or using actual Tyrannosaurus rex eggs, which we'll get a little bit about much later in the video, you definitely make certain that they're in an incubator that's warm, humid, and it's also sterile, so you don't have any contaminants, bacteria, chemicals, or otherwise. Now, what a Tyrannosaurus incubation period is, it's anyone's guess. But according to some scientists, the big dinosaurs' incubation period will probably be between 3 to 6 months. So we'll go with that. But there are also some ways that we can tell when the Tyrannosaurs are ready to hatch. Now, when the Rexlings, that'll be one of my nicknames for them. When the Rexlings are ready to hatch, they'll most likely set out a sound to try to call out to the mother. In birds, this is known as peeping or piping. Birds and crocodilians are known to do this when they're ready to hatch to call out to their parents. With what's been observed in some birds, like kiwis, the Rexlings might be able to hatch better in a mental sense if they were receiving a call from their mothers, pretty much encouraging them to break out of their eggs. Now, obviously, with the first generations, we will not know if Tyrannosaurs do this, or even if they did, we don't know what exactly the call sounds like and such. And it's probably most likely infrasound for the Tyrannosaurus. But we could be able to do this when we get the next generation to breeding age and start breeding and raising chicks themselves, and be able to record the audio. But until then, we'll just have to work without it. There is also the possibility too that, much like birds and other egg-laying vertebrates, the Rexlings might have an egg tooth on the end of their snouts, which would help them be able to break out of their shells. Generally, this egg tooth falls out after sometime after hatching, pretty shortly usually.
There would be occasions when the hatching offspring might have struggles with breaking out of their shells and would need assistance. This would need to be done carefully when assistance is needed, for the shells could injure the hatching Rexling. Also, if the offspring is rushed, the navel may not have properly closed. An infected navel would lead to a dead Rexling. If a dried umbilical attachment is still present, looking like a large coarse hair, it should be pulled from the navel and the area treated with iodine. If this procedure is not followed, the risk of navel and yolk sac infections may increase.
When handling a newly born Tyrannosaur, or any other dinosaur for that matter, it'd be best to handle them when you're wearing gloves, face mask, and glasses. So that way you can keep infections to the infant Tyrannosaur to a minimum. while making certain that the Rexlings are okay during and after their birth or hatching is definitely important, how the Tyrannosaurs were raised is also equally important as well. Now, while we might be able to get away with this with the first generation Tyrannosaurus, later generations Tyrannosaurs, if we had to hand rear them, we would have to use puppetry, something similar, so that they can be able. So basically, because we just like a lot of animals, especially birds, it's likely that baby Tyrannosaurs would imprint on the first thing they see when they hatch, and the last thing we want is them to imprint on humans. So we would definitely use puppetry or something similar in order to raise the little dinosaurs. However, considering that these guys are pretty big when they're born, and as they get bigger, this can lead to some issues. Now, in order to deal with the Rexlings, especially as they grow, I would recommend of using animatronics, similar to what's being used for movies like in Jurassic Park, to be able to help raise the Tyrannosaurs. And with the Rexlings to be born at a length of 3 feet, which is basically about as big as a border collie when they're born, it's definitely a must. We'll get more into the animatronics later. Now, I'm pretty sure many of you are wondering, why do we need something like this? Well, that is because so that the T-Rex could be able to imprint on the image of a T-Rex and not on a human. Confused? Well, if the Rexlings imprint on a human, they won't see themselves as a T-Rex. Or heck, they won't even see other T-Rexes as their own species. And this will lead to a lot of behavioral problems, especially when it comes to breeding. This will most likely make them become aggressive towards their potential mates, and will even see humans as more of a potential mates than we would. And of course, this will bring to a lot of problems. Now, I'm pretty sure you're saying that, then why don't we just use puppets or animatronics right away with the first generation? I would say not yet. For one, we don't entirely know what they look like externally. We're going to have to wait until the first generation grows to full maturity to see that. And B, we need to know if they can display any behaviors or sounds, anything we need in order to help do the next generation better. While motherhood can be a learned behavior for some species, in others it's instinctual, and even so, we still need to learn more about the animals through trial and error, so we can be able to do better for the next generations. One way that we could be able to help make certain that the Rexlings, especially the first generation, don't imprint on humans too much and be able to see themselves as T-Rexes is to make certain they are not raised alone in isolation. Basically, they need to be raised with other Rexlings. When raised with other Rexlings, the Tyrannosaurus chicks would be able to develop proper social skills and be able to have a better idea of what it's like to be a T-Rex. This has been demonstrated with observations done with birds and mammalian offspring raised together with the same species or similar species. As mentioned earlier before, not providing puppets or anything like this would help avoid the behavioral problems that will affect breeding, which we will get to later in the video, and along with other behavioral issues. And once the first generation grows up and we get an idea of behavior, sounds, and appearance, then we could be able to make the puppets look like as they should and have them behave as they should. However, like mentioned before, since T-Rex are huge, even when they're born, like 3 feet long, as mentioned earlier, as big as a border collie, a hand puppet like this is not going to do well for you. So, same kind of animatronics we use for movies can definitely make a good puppet of sorts to be able to raise the T-Rex. But even this does have some issues. Making and designing these animatronic puppets would definitely be quite the challenge, engineering challenge, for they actually can get pretty strong. While we definitely need them strong for when the Rexlings become teenagers, but at the same time, they could be so strong that they can accidentally hurt or accidentally kill the Rexlings. In fact, the late Stan Winston even mentioned in an interview that the cast and the crew had to be careful with the animatronic because that thing is so powerful that it could kill them. So in the movie, they didn't have to act afraid; they were afraid. So this will definitely need to be fixed when we're designing these animatronic puppets, so that we don't accidentally hurt or kill the Rexlings. Now, another thing we need to do with the animatronics is, at least as the Rexes grow up. Sorry about that. Is basically know what the Tyrannosaurs sound like when they're communicating, especially like which sound means what. This will, because as mentioned earlier in the video, some birds like kiwis are known to make calls that would encourage their chicks to be able to hatch out the eggs with more enthusiasm. But there's also other sounds that we need to know what is what, like a call that would call in the babies to calm to them, or even sounds that is basically a discipline. Because with large or young predators like that, there might need to be some discipline, especially if they get rowdy, and especially if they probably get rowdy to either to each other or to the animatronic. So there's definitely that. As you raise the Rexlings, you need to make certain that they are well fed, and because they will grow and they will eventually eat a lot. We covered some information about how to feed Tyrannosaurs in my last T-Rex video. You can take a gander on that, but let's also go over some of the basics. When giving the Rexlings a well-balanced diet, not only do you need to give them a lot of meat, but you also got to make it have a great diversity of meals as well. And you also got to make certain all has the new vitamins and minerals that are there that help make them grow properly, especially a 2-to-1 balance of calcium and phosphorus, so that they can have proper bone development. And when giving them meat, just skeletal meat, the same stuff that makes your steaks, is not a good option. Because they need more than just the skeleton. They also need the organs, hide, bones. For failing to do so would have them develop a deficiency disorder such as metabolic bone disease, which we'll discuss later. Using processed meat that is made for zoo carnivores would definitely be a good thing to start with on feeding the Rexlings when they're young. But as they get older, you can start giving them animal carcasses. When feeding these Tyrannosaurs as they are being raised, it's a huge undertaking, and you will definitely need to make certain you have a stable, reliable supplier to be able to provide you the meat that you need for the Tyrannosaurs. Not just a meat processing plant that could be able to make sure they can provide the processed meat food for you, but also a farm or a ranch, either you have yourself or you can have a partnership with that's independent. You would definitely need to have that there when you want to give the Tyrannosaurs their carcasses later on. the first animal carcasses you would give to the Rexlings would basically be small animals, like primarily rats and rabbits. And then as they get older, pigs and even cattle carcasses could be used as well. Not only that, these carcasses would give the Rexlings all the nutritional requirements they need, like cooling organs, bones, hair, fur, and all that, but it would also be an easy way to be able to hook in medications or vitamin supplements inside the carcasses, so at least the carcasses that the Rexlings can swallow, so that without having to struggle with the Rexlings to give them their vitamins and minerals. When raising a Tyrannosaur young, you also gotta be careful about infectious diseases that can affect them as they grow. As mentioned earlier in the video, when you're handling them, especially when they're very young, having gloves, a face mask, and goggles would definitely be a way to help prevent spreading disease. And also a strict hygiene policy on handling the food is also a must as well. Like even with the carcasses, like the animal carcasses, you'll need before you feed them to the offspring, you'll need them to be in a freezer for at least a month so that it can kill off any parasites that the carcasses could have.
Food security protocols essential when preparing and storing food would include as follows. Perishable foods like meat and vegetables should be stored separately in refrigerators that are regularly checked. Separate utensils like knives should be used for meat and non-meat products to avoid cross-contamination. Feedstock should be rotated as it is being used and controlled by an ordering system which reduces waste.
The ailments that would also be able to affect the Rexlings as it would to the adults is explained in more detail in my last Tyrannosaur video. But for this video, we'll focus on some different ones that would be more directed towards the younglings. And one of them would be metabolic bone disease.
In zoos and other captive animal settings, metabolic bone disease, or MBD, is a common condition, particularly in reptiles, caused by nutritional imbalances, especially deficiencies in calcium, phosphorus, or vitamin D, leading to weak and fragile bones. MBD has a range of symptoms, including weakened bones, increasing the risk of fractures and bone deformities. Deformities causing a curvature of the spine, soft jaws, and swollen limbs. Muscle problems, including tremors, muscle weakness, and paralysis. And other health issues, including anorexia, lameness, and even death. The causes of MBD would be either calcium deficiency, imbalance, or vitamin D deficiency, or even both. Making certain that the Rexlings get that perfect balance of calcium and phosphorus is a must. But even that would be all for nothing if there's no vitamin D into the equation, since that vitamin would help the body be able to absorb and process the calcium properly. You could be able to supplement with a simple exposure to sunlight or UV lights to help them get some vitamin D. If this couldn't be done, there are vitamin supplements that could be added into the meat. The best way to avoid this is to prevent it, and this could simply be done by making certain that the Rexlings have their appropriate amounts of calcium in their diets and making certain that they have their time under sunlight or UV lights for vitamin D. If the signs of MBD could be detected early, a change in the Rexling's diet can reverse the disease before it got worse.
Another medical issue that the Rexlings will probably deal with is related to their teeth. Now, unlike mammals, like you and me, Tyrannosaur will actually lose their teeth quite often. At least once a year. At least around once a year. Slower than that of some other predators like Allosaurus and Spinosaurus, who Spinosaurus loses their teeth once every 60 days, and Allosaurus every 100 days. But definitely more so than humans. Now, with this in mind, also there could be times when the tooth is the tooth is having a hard time getting out as the other tooth is starting to grow. So this is something to consider when taking care of the Rexlings' health. And basically, you have to keep an eye on this, and probably the best signs of this would be not eating as often. Like, it could probably hurt and infection going on. So then the best way to do that is the best way to treat it is get the tooth that's stuck out and get antibiotics and make sure that the animal is eating properly afterwards. When raising Rexlings in captivity, it's best to be able to have them and give them an enriching life. Raising them isolated in a barren environment will not do well for them. It will make them develop behavioral problems, such as stereotypical behavior and so forth. So enrichment is a must.
One form of enrichment would be toys and other enrichment items that are safe for the Rexlings and could withstand their jaws and power. This could range from boomer balls to puzzle boxes. Having enrichment items that have food in them would definitely serve as a grand form of enrichment for the Rexlings, but make certain that the food doesn't stay in that item to the point that it rots.
Enrichment that would also tingle the Tyrannosaurus' senses is also a really good enrichment for them. Tyrannosaurs have a very strong sense of smell, so leaving like scent trails, whether it's of food or just novel, unique smells, would be very enriching for the Tyrannosaur. And even in the enclosure, some modifications to the enclosure can help with that as well. Like, there was a polar bear exhibit, I forget which zoo, in Texas, that has an elevated area where polar bears can be able to get to an elevated area so they can be able to smell the scents around the surrounding community. Something like this for Tyrannosaurus would definitely be a good enrichment, especially for the Rexlings. And also, this will also help with the Rexlings in their sight as well. It has been discovered that Tyrannosaurs have an eyesight that rivals that of hawks and eagles. So having an elevated platform so the Rexlings can be able to observe their environment that's outside their enclosure can definitely be a good thing for them as well. And also, nature sounds, like the sounds of nature, like from birds and stuff like that, can be a good enrichment for them as well, especially when they hear something different. And this could be debated, but music, especially if the music's not like loud and crazy like rock music, even like country music even, could probably be a good enrichment for Tyrannosaurus as well. So for their senses, enrichment for their senses would definitely be a good enrichment for them as well.
Having the Rexlings raised together in a group or even as a pair could also be considered as enrichment as well. Along with helping the Rexlings develop social skills, this could also be good in enrichment opportunities that require multiple individuals. While we have no concrete proof of T-Rex in particular living in packs, we have more proof of Tyrannosaurs being social than we do of the raptors.
As we raise the Tyrannosaurus, you gotta keep in mind that these guys have quite a growth rate. When they're born, in the first couple of years, they would be pretty small, about the size of a border collie to a large dog, but they do grow quickly. For example, a 5-year-old Tyrannosaur, while definitely smaller than the adults, is still pretty big, like between 15-20 feet long and about 5 or 6 feet tall, and weighs several hundred pounds. A 7-year-old, while still significantly smaller than an adult, is still pretty big, like 21 feet in length and weighing in at 3 tons. Note that during these young growing years, the young's build is more slender, more light-foot, more capable of running at fast speeds compared to an adult Tyrannosaur's larger, more robust build. So this can definitely have an effect on working with them. A 10-year-old Tyrannosaur, who I would call a nano, would have been roughly 25 feet in length and weigh around 3,500 pounds, and stood at 10 feet tall, based about 2/3 of the size of a fully grown adult. At 14 years, the size and weight would be pretty similar to that of a nano or 10-year-old, but this is where the Tyrannosaurus would experience one heck of a growth spurt. In the time between 14 years and 18 years of age, these tyrannosaurs will go through an exponential growth rate of growing to 5 pounds a day. And by the time they reach 18 years of age, they're pretty much nearing adulthood at lengths of lengths of 40 to 43 feet in length, heights of 12 to 13 feet tall at the hip, and weighing up between 6 to 9 tons, pretty much becoming fully grown at this point. While they would grow continuously afterwards, it's immensely slow. And mind you, the oldest T-Rex found in the fossil record is up to 28 years. And that's just in the wild. In captivity, they might be able to live longer if everything goes well, probably up to 30s. Think like as long as a horse could live. As the Rexlings grow, especially during their crazy growth spurts, you will definitely need to change the amount of feed or increase the amount of feed for each individual needs, and definitely keep an eye on the nutrients as they grow, especially when they get to their teenage growth spurt, because failing to do so will cause a lot of growth defects. According to the fossils, Tyrannosaurus rex will reach sexual maturity at the age of 18. So, to prevent male-on-male aggression and prevent inbreeding when the breeding urge kicks in, you will need to have plans on separating the rexes before the puberty kicks in. How we do this would depend on the social structure of the tyrannosaurs and see how they compare to that of modern species. With this in mind, we will now start on the topic of breeding Tyrannosaurus rex in captivity. Obviously, to have Tyrannosaurus rex populations grow without having to rely on expensive means of resurrecting more individuals, you will need to breed them. Although, you will still need to resurrect more Tyrannosaurs as time goes on, so you could be able to have multiple individuals that would make a diverse gene pool for the founding population of Tyrannosaurus, so you don't deal with an inbreeding depression and so forth. However, this might be as easy as this might be just easy as being said and actually being done. Primarily because there are several factors that go into the success of breeding these animals in captivity.
We do have a good idea of when they reach sexual maturity thanks to the discovery of a medullary bone in T-Rex specimen. Medullary bone is a specialized, porous bone tissue found in the inner cavities of bones in female birds and dinosaurs during the egg-laying cycle. It acts as a calcium reserve for the formation of eggshells.
But we have no idea when a Tyrannosaurus mating season is by month or season at this point, although it has been theorized that they might breed in the dry season so that the eggs can hatch into the rains. Along with physical changes, environmental factors can also contribute to the start of the mating season, and factors would include, but are not limited to, food availability. Some animals would often time their breeding seasons to coincide with periods of abundant food resources, ensuring their offspring would have a better chance at survival, much as I mentioned earlier. Seasonal changes in day length, known as a photoperiod, temperature, and rainfall can act as signals for onset of breeding seasons. For example, deer would start breeding when the days are getting shorter, and horses would start breeding when the days are getting longer, as examples. Nesting materials. The availability of suitable nesting materials can also influence the time of breeding, especially of plants. Predation risk. Some species would start breeding when the risk of predation is significantly lower, and that will increase the chances of their offspring's survival. Regardless, even when we figure out the Tyrannosaurus' breeding season, it still will not be easy. We'll need to see which individuals would be genetically compatible with each other, especially to avoid any sort of inbreeding that would decimate future T-Rex offspring. A Tyrannosaurus Rex stud book, basically a pedigree book for managing the breeding of animals, would need to be developed in order to help avoid this. And even then, once a stud book has been made for Tyrannosaurus and the individuals are selected, we also got to make certain that those said individuals are healthy. While many of the elements that would affect Tyrannosaurus Rex breeding was mentioned and described in detail in my last T-Rex video, there is another element that would be a specific issue for Tyrannosaurus breeding. Just like how humans can get herpes, birds can get it too. And in this case specifically, the pigeon's herpes virus, which is a herpes virus that causes inclusion body disease or inclusion hepatitis in pigeons, and it also affects raptors or birds of prey like owls and falcons, often through the consumption of infected pigeons. There is a possibility that Tyrannosaurus could be affected by this as well. On pigeons, the symptoms or clinical signs may include depression, anorexia, inflammation of the eye membranes, difficulty breathing, ulcers in the mouth, and diarrhea. In raptors, or birds of prey in this case, symptoms will include depression, lethargy, and anorexia before death, with mortality rates approaching 100%. In raptors, this is primarily the infection is primarily thought to occur with the ingestion of infected prey, especially pigeons, hence the name. To prevent this, preventing Tyrannosaurus from consuming infected pigeons is a must, and ways on how to limit the number of birds in a Tyrannosaurus' exhibit has also been described in my last T-Rex video, in case you're interested. But even if we get this all sorted out, it still is going to be tricky since we have a minimal idea of how Tyrannosaurus Rex breeding patterns would go. The best we can be able to tell is from looking at the mating patterns of modern day animals, especially at crocodiles and birds that are the closest living relatives to T-Rex, and from what we can find from trace fossils that are found on the fossil record. This will give us some ideas on how the Tyrannosaurus will probably do mating patterns. One possible behavior that the male T-Rex would do in the breeding season is, like crocodiles and alligators, they will become more aggressive and territorial, and will make bellows and other vocalizations along with scent marking via urination and or defecation to announce their presence, which will both attract females and intimidate rival males. While this is within the realm of possibilities, since Tyrannosaurus is more closely related to birds, looking at how birds do their mating patterns could definitely be able to help us out with this. And there are a few ways how birds do that. T-Rex could probably do it too. Elaborate displays, as many male birds perform intricate dances, flights, and other visual displays to impress potential mates. While we're not certain on Tyrannosaurus, we have found evidence that theropod dinosaurs, especially the large ones, did do elaborate displays very similar to that of modern birds. Bright plumage. Some males develop bright, colorful plumage of their feathers during the mating season to signal their health and vigor. While the idea of Tyrannosaurus having feathers or not is still hotly debated, male Tyrannosaurus could still be able to have some very colorful plumage, or even have very colorful scales on their faces, throats, and chests to be able to make a colorful display to show their health and attract females. Singing. Many species of birds will use songs in order to attract mates and establish territories. While it is obvious that Tyrannosaurus may not be able to sing as like a little Tweety bird, it will still make sounds, even infrasounds, to communicate and attract females. The territorial bellows mentioned earlier in the video could still probably count as singing. Food gifts. Some male birds would offer food or other valuable items to potential mates as well as part of their courtship. That could be a possibility for tyrannosaurs that they might use food or maybe something of a simpler color like that of bowerbirds to attract females. However, it's just uncertain at this point. Nest building. Some male birds participate in nest building, demonstrating their ability to provide a safe and suitable environment for raising chicks. As mentioned before, there are fossilized there are trace fossils that show dinosaurs, at least large theropods, doing mating displays, and amongst these is ground scraping. Scraping, when done with modern birds, is basically to show that either A, that the male is very strong, macho, or B, that the male is able to make a good nest by being able to scrape up the earth efficiently to make a proper nest. Oh. But either way you look at it, there's no guarantee we'll know the complete answer, even if we resurrect the T-Rex. I say that because, while mating habits can be genetic traits, it's also learned as well, especially on the quality of the mating displays and behaviors that the male would display. A good example of this is that at one time when the kakapo, New Zealand's flightless parrot, were fewer in number, the most genetically important birds, due to them being young and inexperienced, their mating displays were less attractive than the males that have bad genetics. But those genetically superior males did eventually learn how to perfect their mating displays by observing the males that had the better displays. While this might not be the exact situation you might face with Tyrannosaurus mating displays, it is definitely something to consider. Before you consider breeding those two individual tyrannosaurs, you need to be able to introduce them gradually to each other so they don't perceive each other as like a threat or a competitor for their food or territory. So basically, first impressions are key. You do gotta remember that these dinosaurs are huge, weighing a maximum of 8 or 9 tons when fully grown and armed with immensely powerful jaws. All that should tell you that if these animals would fight, the carnage would be immense, terrifying, and potentially fatal to the tyrannosaurs, either to both of them or to one of them. And it has been documented that tyrannosaurs and other theropods are known to be cannibalistic towards each other, so that is definitely something to watch out for. Mind you, that it could be possible that the cases of when Tyrannosaurus cannibalism takes hold is due to drought or some other environmental stress. Offspring raptors or birds of prey have been known to cannibalize on the younger, weaker sibling when food is scarce and the parents are not bringing any. And this may be something to consider when dealing with little rexlings. However, crocodiles and Komodo dragons have been known to cannibalize on another member of their own species if they're smaller than they are. So, this might be something to consider when introducing them to each other. Now, one way that we can be able to help them get introduced to each other, well acquainted with each other, is by olfactory means. By that I mean that to exchange bedding, enrichment items, and other items between the two animals' enclosures so they will allow them to familiarize themselves with each other's scents. This might also even help you see if they're ready to mate, especially since tyrannosaurs have a powerful sense of smell and might actually respond to the hormones within the scent that will basically indicate that like the female is an estrus or anything of that nature. Along with this, an extra way to get them used to each other is to place them in enclosures that are right next to each other, so they could be able to see each other without having to get physical contact. Basically, a barrier in between them. This way, they could be able to get to know each other and not see the other as a stranger or a potential enemy. When they go through this, have the zoo staff, including keepers and behavioral specialists, monitor the animals closely throughout the process. If the signs and behaviors they display are positive after weeks or over a month, then the next stage could be done. But if they're negative, depending on the situation, it would be best to get them away from each other. If they're showing a good behavioral signs towards each other, set them up for short supervised interactions. Basically, as you do these short periods of interaction, gradually increase the duration as the animals become more comfortable with each other. Keepers and behavioral specialists should be present at all times to intervene if necessary to ensure the animal's safety and well-being. Some of the signs that show that they are getting along could be some of the main displays that were mentioned earlier in this video, and no doubt that it will be quite a show for those present to watch. Another possible sign that they will be able to start liking each other is that they would possibly be, after displaying or such, they could possibly be rubbing each other's faces against the other. Since we actually show that fossils have shown us that they actually have nerve endings and the nerve endings into these areas here that makes this part of the area as sensitive as your human fingertips. Animals with similar features are known to be able to rub or touch each other for friendly or affectionate purposes, so it'd definitely be no different for T-Rex to do this either. So it would definitely be in a sweet scenery. But the fossil record also shows us that if things go south, the Tyrannosaurs will generally attack each other by biting each other's faces, which will lead to serious injury. In case this happens, having a couple of high-powered fire hoses on hand would definitely help separate them from each other if they are fighting. When breeding, most birds would do what is known as a cloacal kiss, which means that the cloaca is basically the hole where they poop, pee, and breed through. Unlike mammals who don't have this sort of thing, they would just briefly touch each other to allow the transfer of sperm from the male to the female. Now, since Tyrannosaurus rex could weigh up to 8 to 9 tons, a cloacal kiss is just not possible. So it's most likely that the Tyrannosaurs will actually have a penis, similar to like that of crocodiles, and that of two different groups of birds that still have the penises, and that would include the family that include the ratites, which includes ostriches and emus, and then there's some of the waterfowl, primarily ducks and geese. So yeah. Moving on. However, if natural breeding could not be done for one reason or another, and this is probably will be the most likely the case for first generation Rexlings, artificial insemination or AI could be possible. Now, there are pros and cons on using artificial insemination. Genetic improvement. Farmers often use artificial insemination to allow breeders to access semen from high-quality sires, accelerating the introduction of desirable traits into herds and improving overall genetic merit. This could be done for Tyrannosaurus too, especially if the traits in general is genetic diversity and making certain they have healthy genes rather than defective ones. Disease prevention. Artificial insemination reduces the risk of STDs compared to natural breeding, as semen is collected and handled in a controlled environment, and even get tested for the diseases. And as I mentioned earlier, this is definitely a must. Increase efficiency. Basically, if you want to be able to breed multiple females to one male in a short amount of time, you could just get the semen and be able to transport them to far off places, to other facilities, in order to do so. That way, the Tyrannosaurus, you can have one male T-Rex be able to breed multiple females across the country. So it definitely would save costs. Controlled breeding. Artificial insemination allows for precise timing of insemination, which will lead to higher conception rates and more precise on gestations and incubations. Use of injured, old, and even dead sires. Artificial insemination allows the use of sperm from sires that are injured, too old, or even dead for natural breeding, especially if you preserve the semen in cryo tanks, extending their breeding potential. This is something that's been being done for several endangered species, especially the northern white rhino, but that's a topic for another video. Reduce risk for animals and humans. Artificial insemination reduces the risk of injury to the animals or handlers doing breeding, as it removes the need for direct contact between the male and female. As we mentioned earlier about the potential risk that the two Tyrannosaurs will present to each other, this definitely goes without saying. As you can see, using artificial insemination for Tyrannosaurus definitely has a lot of pros. But also don't forget that it actually also has a lot of cons into it as well, especially for the case of Tyrannosaurus. Requires expertise and training. Successful artificial insemination requires skilled personnel, proper equipment, and a good understanding of animal reproduction physiology. And considering that we're dealing with Tyrannosaurus, and so far we have not had any preserved reproductive organs of Tyrannosaurus, so it's basically anyone's best guess on what they are like. Higher costs. Artificial insemination requires specialized equipment, steam and storage, and transportation, which can increase costs compared to natural mating. And of course, like I mentioned before, with a unique animal like Tyrannosaurus, that will definitely up the costs. Potential for lower conception rates. Artificial insemination success rates can be lower than natural mating, especially with frozen semen, requiring more time and effort to achieve the desired results. Timing is critical.
Accurate heat detection and proper timing of insemination are crucial for success, which can be challenging.
Risks of infection. While artificial insemination generally reduces the risk of disease transmission, improper handling of semen or equipment can still lead to infections. Ethical concerns. Some argue that artificial insemination can lead to overutilization of certain sires and potential welfare hazards if not managed properly. Difficulty with unknown species. The AI technology and expertise can be limited with Tyrannosaurs and other species unless an immense amount of research on Tyrannosaur reproduction is done. So this is definitely something to consider. Regardless of whether the breeding is done by natural means or artificial means, one sign that shows that the breeding might possibly be successful is that the pair, whether the pair stay together after a successful breeding is uncertain at this point, would make a nest for the eggs. The quote-unquote gestation between the mating to laying the eggs varies from species to species. For example, most birds lay eggs 1 or 2 days after breeding, but some species of bird would take longer. For example, bald eagles would take 5 to 10 days after mating, and lovebirds would lay eggs anywhere from 5 to 12 days afterwards. Female crocodiles typically lay eggs 1 to 5 months after mating. with the exact timing varying depending on the species and environmental factors. It is also worth noting that, unlike modern birds, dinosaurs would have had two oviducts rather than one oviduct, which is believed that modern birds only had that one so they could be light enough to fly. This would mean that the Tyrannosaurus would lay two eggs in a row before a full clutch is laid for the season. While there is no confirmed Tyrannosaurus rex eggs or nest fossils have been found yet, paleontologists estimate that Tyrannosaurus probably laid clutches of about 20 eggs at a time, based on the size of the clutches and nests of other Tyrannosaurus species and general dinosaur reproductive systems. When laying eggs, you definitely still need to watch out for them because there's a possible chance that the female Tyrannosaurs might develop an egg-laying prolapse. In birds, and dinosaurs in this case, an egg-laying prolapse, also known as a vent prolapse or cloacal prolapse, occurs when the reproductive tract protrudes through the vent, often after laying an egg, but does not retract back in, like it should. There are several causes for the for cloacal prolapse. And they include, but not limited to, young or underdeveloped females are prone to this. If they're too young or not fully developed, can have difficulty laying their eggs, which will increase the chances of a prolapse. If the birds are overweight or underweight, if they're fat or very skinny, they will have weaker muscles and making it harder for them to be able to retract the oviduct. Also, unbalanced diets. Nutritional deficiencies, especially of calcium and magnesium, can affect the muscle tone and the ability to retract the oviduct. And those aren't the only causes. Females that are laying proportionally large to or double yolked eggs would strain them excessively during egg laying, and this could potentially lead to a prolapse. Well, that's going to be interesting if it's bigger than usual, because the T-Rex already would lay an egg that's 17 inches long. So, yikes. Poor skeleton development. Prolapse during production is often related to a poor skeleton development during rearing, even if the body weight during the production is at target. The signs of a cloacal prolapse would include a red shiny tissue that is protruding out of the vent or cloaca, blood or feces on the feathers or around the cloaca, and the female would appear depressed, strained, or pretty much just having a lack of appetite. Treatment for this would be primarily of immediate veterinary care. A prolapse cloaca is an emergency and definitely requires prompt veterinary attention, cleaning, and irrigation. The prolapse tissue needs to be carefully cleaned and irrigated to remove debris and egg material. Gentle replacement. The tissue must be gently pushed back into place, but this should only be done via a veterinarian or an experienced keeper. Antibiotics, especially broad spectrum antibiotics, may be needed to prevent secondary bacterial infections, and surgical intervention. In some cases, surgery may be necessary to repair the prolapse or address the underlying issues. Whew. We do this to chickens and even ostriches. Just imagine doing this to a 8-ton theropod. Oh boy. As mentioned, while we have not yet found a Tyrannosaurus Rex nest by the time this video is in development, I think it's safe to assume that T-Rex did not sit on his eggs like chickens and other birds would have. Most likely that a Tyrannosaurus's nest would most likely be a mound nest. Or it would be like a pile of decaying vegetation like a compost pile. Or a mound that's pretty much been dug and made in geothermally active areas. Much like how nests of most crocodiles and megapode bird or mound building birds are. While there is no specific incubation period known for Tyrannosaurus rex eggs at this time, studies on dinosaur egg incubation suggest that it will most likely take between 3 and 6 months for the eggs to hatch, which is significantly longer than predicted for birds' eggs of similar sizes. However, depending on the captive situation, it would be advisable to remove the eggs from the nest so that the hatching success would increase and facilitate controlled breeding programs and ensure the safety of the hatchlings in a controlled environment, often where the natural environment is not unsuitable. And also, of course, this will lead to the subject of raising Tyrannosaurus rexes at the beginning of this video. However, there could be situations where it would be advisable to have the rexlings raised by their biological parents or parent. It's uncertain if they raise their young together, or only the female would raise them, or that's the male that does it, like ostriches do. Either way, there will be times that doing this will be essential, especially able to help the heirs to the T-Rex crown see that they are T-Rex and would develop proper T-Rex behavior under their parent or parents. As one could tell, if we do bring back the T-Rex, we must know how to properly raise them. If we must have more of them naturally, we must know how to breed them. And all of that will not be easy, raising the princes and princesses into the kings and queens of the dinosaurs. If you have made it this far, thank you ever so kindly for watching this video. This one was quite a lot of fun and a lot of information to go through. So it was definitely a lot of fun. I want to say thank you to the sponsor of this video, David Glean. He sponsored a couple of my videos, and he even sponsored a good chunk of the videos for the rest of this year. If you're interested in sponsorship, either contact me on my Patreon page or email me on my email address, and we can go on from there. So again, thank you, David. I also want to say thank you to artist Keenan Taylor. And as many of you know, his art has been really good. Has been really helpful for my channel ever since the beginning. He has really great stuff, and he's got his own little project going on. I will send you a link to his DeviantArt channel in the description box down below. I also want to thank another artist who goes by Taliesaurus. He's done some artwork for my videos last couple of years, and especially for this artwork for this video. I also sent a link to his DeviantArt page in the description box down below. I hope you take a gander and enjoy. If you'd like to be able to support this channel and become a member, check out my Patreon page. Every little bit helps. I will send a link to my Patreon page down below. I also like to thank my YouTube members, my subscribers, and viewers like you. Thank you. Your watching and liking, subscribing, and contributions really help me out. If you haven't already, please like and subscribe this video and this channel. It helps immensely. And I hope that from here on out, each and every one of you has a grand day. Adios!